The quest for life beyond Earth is still in its early stages, but science has an encouraging early answer. There are numerous planets in the cosmos, many with similarities to our own. But what we don't know fills volumes. Observations from both the ground and space have revealed the existence of thousands of planets beyond our solar system. Our galaxy likely holds trillions. But so far, we have no evidence of life beyond Earth. Is life in the cosmos easily begun and commonplace? Or is it incredibly rare? To find out, we start at the edge of the universe. From the flats of rural Australia to the hills of West Virginia, some of the world's largest telescopes are constantly listening for signals coming from distant alien civilizations. The search for extraterrestrial intelligence, SETI, is an effort to find artificial-looking electromagnetic radiation that might have come from a technologically advanced civilization in a faraway solar system. The lack of any data, however, restricted the field for many years. But that changed in 2015, when billionaire Yuri Milner funded the biggest SETI program ever in Berkeley, California. The Breakthrough Listen project to search 1 million stars for signs of intelligent life. Using telescopes in West Virginia, Australia and South Africa, the project looks for radio emissions that come from the direction of a star, and that change steadily in frequency, as would happen if an alien transmitter were on a planet, moving with respect to Earth. The trouble is that these searches yield a blizzard of data, including false positives, produced by earthly interference from mobile phones, GPS, and other aspects of modern life. The biggest challenge in looking for SETI signals is not at this point getting the data, but differentiating signals from human or Earth technology from the kind of signals we'd be looking for from technology somewhere else out in the galaxy. Furthermore, it is impractical to manually review millions of observations. The solution: artificial intelligence. And a new machine learning method has found 8 previously undetected signals of interest, and they are very, very interesting. The 8 new signals may be signs of extraterrestrial life on other planets, as they are originating from stars that are substantially closer to Earth. And those targets, and others like them, mean that artificial intelligence could allow us to finally find signals of life beyond Earth, according to researchers. Much of the hunt for extraterrestrial intelligence looks for techno-signatures, or signals that could have come from alien technology, accidentally or on purpose. But scientists struggle to find those techno-signatures, in part because there are so many interesting candidates, much of which comes from interference. The new system is intended to allow researchers to comb through the vast amount of data coming to us from the universe and help us more quickly pick through to find signals that might be of interest. It has already found 8 promising extraterrestrial intelligence signals of interest not previously identified. However, repeated observations of those targets has not yet resulted in the rare detection of signals that are similar, scientists say. However, scientists are still hopeful. The new system searched through the information gathered on those radio signals, which originated from all around the cosmos. After filtering out signals that appeared to be false positives, they were left with 20,515 signals. Of those, they found 8 signals of interest that grabbed the interest of researchers. The 8 signals come from 5 different stars, all between 30 and 90 light-years from Earth. There are a variety of strange radio signals that have been detected in space, and scientists continue to study them in order to understand their origin and nature. Fast radio bursts, aka FRBs, are extremely short bursts of radio waves, lasting only a few milliseconds. They are extremely bright and can be detected from billions of light-years away. Scientists are still trying to determine the cause of FRBs, but some theories include supernovae, black holes, or even extraterrestrial civilizations. Overall, strange radio signals can offer an exciting opportunity for scientists to explore the unknown and potentially discover new phenomena in the universe. However, it's also important to approach these signals with a healthy dose of skepticism and to critically evaluate any claims about their origin and nature. Back in 1977, while reviewing a recorded data, astronomers discovered a strong narrowband radio signal detected by the Ohio State University's Big Ear radio telescope. The signal appeared to come from the direction of the constellation Sagittarius and bore the expected hallmarks of extraterrestrial origin. Astronomer Jerry Oreman, who detected the signal, was so impressed by the result that he circled on the computer printout the reading of the signal's intensity and wrote the comment, "Wow," beside it, leading to the event's widely used name. The entire signal sequence lasted for the full 72-second window, during which Big Ear was able to observe it, but has not been detected since, despite several subsequent attempts. Many hypotheses have been advanced on the origin of the emission, including natural and human-made sources, but none of them adequately explain the signal. The WOW signal remains the strongest candidate for an extraterrestrial radio transmission ever detected. Since then, we have detected countless radio signals coming from several directions. One of them came from the direction of Proxima Centauri, arising hopes in the hearts of several people that an alien civilization from our nearest star was trying to contact us. It turned out that the radio waves were created by human-made technological anomalies. And now, astronomers have captured a radio signal from the most distant galaxy so far. The radio signal captured was found to have a wavelength of 21 centimeter line, researchers from Montreal and India revealed in a new study. This signal came from the most distant known galaxy SDSSJ0826 plus 5630 and may help researchers look back at the early universe. Astronomers used the giant meter-wave radio telescope in India to detect the signal. It is the first time this type of radio signal has been detected from such an immense distance. A galaxy emits different kinds of radio signals, says Arnab Chakraborty, a postdoctoral researcher at McGill University. Until now, it's only been possible to capture this particular signal from a galaxy nearby, limiting our knowledge to those galaxies closer to Earth, Chakraborty added. He noted that researchers used a naturally occurring phenomenon called gravitational lensing to capture a faint signal from a record-breaking distance. Gravitational lensing term was coined by Albert Einstein and describes when closer objects act as a magnifying glass for distant objects. Essentially, gravity warps and magnifies the light of distant background galaxies. This will also help us understand the composition of galaxies at much greater distances from Earth, Chakraborty said. In the study, the researchers said they were able to observe the distant galaxy's atomic mass of its gas content. And what they found was that this particular galaxy is almost twice the mass of the stars visible to us. The team said the detected signal was emitted from the faraway galaxy when the universe was only 4.9 billion years old. This allowed the researchers to glimpse into the secrets of the early universe, a press release from McGill University reported. It's the equivalent to a look back in time of 8.8 billion years, explained Chakraborty. In the future, researchers hope to use artificial intelligence to scan through and pick data quickly. Advancements in AI will take humanity to new leaps and bounds, and the future looks absolutely amazing. What do you guys have to say? Do you think we will ever make contact with an alien civilization? And will it be artificial intelligence that will finally help us find an answer to the biggest question? Are we alone? So, would you like to travel to the other side of the universe, or stick with us here, at the edge of the universe? Until we meet again,